Hello and welcome back to the Midmind revision series. Today we're going to talk again about mathematics and again about fractions. Today we're going to talk about adding fractions specifically. I do have other videos on simplifying fractions, so presenting them in the most simplistic form, and comparing fractions as well, which is very similar to adding fractions, but there are a few more applications when we actually have to add them together. We can use them in arithmetic questions, so upper key stage 2, you're going to get some adding fractions questions in an arithmetic paper. As I'll show you today, at least one example of, there are also adding fractions questions in reasoning papers as well. So let's get straight into it. Again, this is very similar to comparing fractions. You are going to need to change or be really, really adept with learning how to make the denominators the same. That is my annoying phrase for this: make the denominators the same. I'll show you what I mean in an example here. So we have an arithmetic question, year 6 SATs, question 17, 5/7 add 3/21, 3 over 21, say it however you like. But we can't add these together at the moment because the denominators are different. However, keen-eyed amongst you should recognise that both these numbers are in the 7 times table. If you don't, then what you want to do is just work out your 7s down the side: 14, 21, 28. With these type of questions, you're likely to only have to change one of them. Unfortunately, we do. We can leave the 21s, the 21ths, as they are. And we just need to alter the 7ths to make them also over 21. And again, I'm going to draw a ring around this original fraction. So I note to myself what I need to do. I need to multiply the whole thing by 3 because 7 times 3 is 21, 5 times 3 is 15. Now I can just use both of these. They're both over 21 or in 21ths or 21st, so I'm not really entirely sure the right way to say it. We do 15 add 3 and we get to 18 over 21. Now that will do. It would be great if we could write them in the most simple form. So remember when we were actually simplifying, it's an extra step. See if we recognise, okay, which times table are both these numbers in? Do we know that? Can we half it? Can we divide by the denominator? Well, I can't divide by the numerator at the moment. I can't divide both of these numbers by 18, but I know they're both in the 3 times table. Okay, so I'll divide them both by 3. 18 divided by 3 is 6. 21 divided by 3, as we've seen there, is 7. So you could put 18 over 21. That is a correct answer, or you could, gold standard, write the simplified answer of 6/7 in there. Okay, so what if I can't just make them the same? So a level of difficulty up, we've got 1/2 add a 5th. I can't just double the half to make them quarters. I can't divide. There's nothing really I can do here. So I need to work out what denominator I can make both of these. So I'm looking for what's called the lowest common multiple. I need to know a number that's in both of these times tables so I can make them same. So I can't just double it, I can't make it 4, etc., etc. You can see these two numbers here, and if you don't know your times tables very well, you can't see a number, you can't immediately notice a number, start writing down the times tables. Use your toolkit. So I'm going to write down my 2s, 2, 4, 6, 8, 10, 12, 14. And then I'm going to write down my 5s. 5, 10, 15, 20, 25. And then I'm going to look in the list with my wiggly line. I can see there's 10 in both. So it's the lowest common multiple. The lowest multiple of both of these numbers. Well, they both have a 10. So remember to put an add so we didn't drop any marks there. And then we just need to adapt these. We need to change how we're presenting them. So we've got 1/2 and we're going to turn it into tenths. To turn it into tenths, we need to multiply by 5. 2 times 5 is 10. 1 times 5 is 5. I'm going to do the same thing over here. I've got fifths currently. What do I need to do to make 5 into 10? I need to multiply it by 2. 5 times 2 is 10. 1 times 2 is 2. 5 add 2 is 7. Keep it in tenths. Quick check, can I simplify it? Well, I can't divide it by 7. I can't divide it by my numerator. I can't halve them because otherwise I'll have 3.5 up here. I won't have an integer. So I'm just going to leave that at 7/10. Toolkit, very useful. It only takes 20 seconds, but it can really it can improve your accuracy on almost every question. Those are the two types of questions you're going to get on an arithmetic paper. And here is an example of a question that you get in a reasoning paper. So question 14, write these fractions in order starting with the smallest. If you need to remember detail of questions, I know it's involved, but you could underline it or ring it. And a pitfall that people will fall into here is, okay, I've got fifths, I've got quarters. Well, I know that 3/5 is going to be smaller than 6/5, that's obvious. And then I'm going to have to guess 3/4, maybe it goes in between. You can't be guessing. So we need to make sure that we find, again, the lowest common multiple. How to do that is to write down our 5 times table, 5, 10, 15, 20. If it doesn't immediately come to mind, take seconds. Then write our 4s down, 4, 8, 12, 16, 20, 24, that'll do. The lowest common multiple there is 20. Scribbly, scribbly. But we need to convert each of these fractions into 20ths. To make it easy on myself, I'm going to write this below. 6/5, 3/5, 3/4. Okay, so same method every time. Writing a ring around it to remind myself to multiply the numerator and the denominator. What do I need to do to 5 to make it 20? I need to multiply by 4, so I'm going to do the same to the top. 6 times 4, 24 20ths, an improper fraction because the numerator is larger than the denominator. Same thing here, have 5, I need to make it 20. 5 times 4 is 20, 3 times 4 is 12. And then slightly different over here, 3/4. 4 times 5 is 20, 3 times 5 is 15. So I'd go back to the originals because they're asking you to order these fractions, not your altered ones. So I'm starting with the smallest. I've got 24 20ths, 12 20ths, and 15 20ths. So I'm going to put 3/5 over here. And then I'm going to pick 3/4. And then I'm going to put 6/5 over there. I'm going to give myself a mark and a pat on the back. So again, here's the method. Find the lowest common multiple. If you can't immediately tell that we could convert these all to 20th, that's fine. Do your 5 times table here. And do your 4 times table over here. Only takes a second, or it should only take a second. Convert the fractions so the denominators are the same. We're all in 20ths. I've even written them down over here, so I'm nice and neat, I'm organised, and then you can directly compare. And it didn't actually take much longer than an arithmetic question even. So the beauty and the work is in the setup. Actually answering the question isn't too difficult, but we're going back to the same method every single time. Make the denominators the same. Use a toolkit if you need to, then answer the question after that. If you aren't noticing that 5 and 4, we'll convert these to 20ths, that isn't immediately clear. Maybe it's something, an indicator that you need to put a bit more time into times tables. Learning times tables speeds up everything. It's a cheat code to all of maths. It's really, really important. You could do times table rock stars, whatever you need to do. Use flashcards, get something to test you every night. But if you could learn your times tables, it would make life so much more easy because it frees up working memory in your head. If you've got to constantly calculate a times table whilst you're almost got a fraction held in your head as well, or whilst you're doing a long multiplication, it's using up your working memory. Its cognitive load is too much and you're likely to drop a number, forget what you're doing, write it in the wrong spot, just make a silly error. If you've got those times tables instant, it's going to make everything seem automatic. You're going to breeze through everything. The annoying phrase is make the denominators the same. And it's a good phrase in pretty much any fractions question. Set yourself up. If you can make the denominators the same, you can add, you could also subtract, you can do lots of things, but try to do that first whenever you see a fractions question. And then everything is denominated in the same unit. And final tip, use a toolkit if you can't see how to make them the same. So if you're not sure of your times tables, take time, write them down the side first so you don't have to hold it in your head. You don't need to burn up that cognitive load and you're ready to go. I hope that was helpful. I've put down an incomplete title up here. There should be adding fractions, but the same thing applies really. If you're making the denominators the same, then you've got every chance of answering these questions, whether it is a reasoning question or whether it is an arithmetic question as well. Please, again, let me know what subjects you'd like to know more about. I know fractions is a particularly challenging topic. People freak out when you see fractions questions. So let me know what you're getting stuck with. Post up some questions if you like. You could always visit my website at mintmindtutoring.co.uk. Post me up a problem there and visit the contact me page, and I will post up some more videos for you and help you out. See you again soon. Ciao.